All right, so in the previous example, we talked about the issues related to ownership and the fact that sometimes it's very inconvenient to actually sort of pass control of the variable into a closure and then return that value just so that you can return the ownership. So one of the notions which is supported by Rust is called borrowing. So let's take a look at how this actually works. I'm going to leave the print vector thing here, but I'm going to get rid of everything up above so that we can sort of we can start over again, so to speak. So let's suppose that we have our vector v with values 3 to 1, for example, and then I want to call print vector. Now, instead of letting the vector take ownership of my vector, I can pass a reference to it by putting an ampersand in front of the vector. So what this is basically saying is that instead of giving over control to print vector, I'm letting print vector borrow my vector for a while. And of course here what I have to do is I have to change the type of the argument from an ordinary vector to a reference. So I'm going to take a reference here, and there is no longer any need to return the vector because this is just fine. You know, we can take the vector, we can print line, for example, the first element like so, x at 0. So we can do something like this, and this will work just fine. So as you can see, we're simply borrowing the vector for a while so that we can perform some operations on it. And of course, the reference that we have here is immutable, meaning that something like x dot push 1 to 3, for example, this isn't going to work because at the moment we have an immutable reference. And we'll talk about mutable references in just a moment. Okay. So the consequence of this is that after calling print vector, it is perfectly legal to perform the same thing here. So it's perfectly legal to access the vector after after it's been borrowed, because it's been borrowed as opposed to taken over. So we can essentially print out the first element here as well. So here you go, x at 0, v at 0. So everything is fine. This is a much more convenient thing. Now let's talk about mutable references. So let's suppose I have some mutable variable called a with a value of 40, for example. What I can do is I can try to, well, first of all, let's talk about how the borrowing actually works. So let's suppose I make a variable called b, and b actually does a borrow of a. So b becomes a mutable reference to a. And let's suppose, for example, that I want to double a through b. So I take this mutable reference and I say, let's follow the reference. By the way, the star in front of the reference essentially lets you access what the reference is actually referring to. In our case, the reference b is referring to a variable a, and therefore to access the memory, we write star b. So let's increase it by 2, for example. Okay, so now if we try to print line, let's print line a is equal to a like this, then we're unable to use it. Why can't we use it? Well, because you see, what happened is b has essentially borrowed a, and so we cannot use a until it unborrows it, until it releases a from its control. How can we get it to do that? Well, one of the options, as before, is you would put in the scope here. So if we put in the curly braces, what happens is b only lives inside the curly braces and it stops existing outside. So we have a mutable variable called a, and then in this scope we borrow this variable, we perform some manipulations on it, but then b goes out of scope, so it releases a, and therefore printing a is actually valid. And if we run this now, then everything is good as before. So this idea of mutability, it basically tells you that, there is a rule for protecting against data erases, and it goes something like this. You can have more than one reference to a resource. However, there can only be one mutable reference to a resource, which means that, for example, if I had something like let c equals a, for example, this wouldn't affect compilation at all. This would work just fine. The only problem is that A is mutable, and borrowing it as an immutable is kind of bad. It's not something that we can reasonably do. So this is something that is worth keeping in mind. Incidentally, if I remove mutable from A, then you're going to see a different problem. So you cannot borrow an immutable variable as a mutable. So the borrow has to basically match the mutability of what you're borrowing, which is why we should have the mutable in here. So let's take a look at our final example where we're going to have a mutable vector. So let mutable z as a vector of 3 to 1 once again. And what we're going to do is we're going to iterate through all the elements in a vector, but we're going to iterate like this for I in a reference to z. So we're now taking a reference to this vector, and what we can do is we can certainly print line the particular element. We can say that z at a particular, so let's just say I is equal to, and then print the element of the vector. So this is something that's going to work just fine. I equals 3, I equals 2, I equals 1. However, once again, this idea of pushing into a vector, for example, even though it's declared mutable, if I say z.push, let's say 5, for example, this isn't going to work. Now, let's think about this for a second. Why is Rust preventing us from doing this? Well, imagine you're iterating an element. You're iterating the elements of a vector, and you keep adding elements to it. This clearly would result, if it were allowed, it would result in undefined behavior. Instead, Rust prevents us from doing this, and thereby it enforces some of the memory safety. And these are some of the problems which plague other programming languages, but in Rust, you have defenses against this sort of thing.